Hello, everyone. I need to research how people handle their complicated, like, what's the trick to the OBS workflow? Because I'm always like, oh, click this to hide favebot, click here to hide stream starting soon, click here to hide, etc., etc. Hello, everyone. Happy Tuesday. It is me, Minu. Um, We're here to do another little code practice stream. We are. Oh my god. Don't be giving away. That doesn't count as an incident. You all can email me if you want to. Not super sensitive thing. But for now we're bidding farewell to Cosmo the Space Dog. See you, Space Cow Dog. And instead we are using this website. The reason for this is that we have secured a technical interview for a job. Everyone say congratulations, fairies. Well done, fairies. And they're like, here, you should do these to prepare. And I'm like, sure, okay, I'll do them to prepare. So, I'm at least gonna take a look through this, and this might be more kind of like what I originally envisioned coding practice would be, was just doing weird problems, but maybe these problems are too weird, and then I'll be like, oh no. There's 10 sections. Um, all of algorithm. And trapping rainwater. Well, that sounds poetic. So anyways, at least we'll give it a try for today. If it gets too boring, who knows? Maybe we'll go back to what we were doing before. Especially if I start falling asleep. Let's see. Given an array of n non-negative integers R, I'm a pirate, representing an elevation map where the width of each bar is 1, compute how much water it is able to trap after raining. Input R202, output 2. Explanation, the structure is like below. We can trap 2 units of water in the middle gap. And in this one, we can trap 1, 2, 3, 4, 5, 6, 7. Right? Yeah. And the structure is given by, okay, I see. I understand. 1, 2, 3, 4, 5, 6. Like weird, fucked up Tetris. But, like Tetris is how we should do it, right? We should design an algorithm that just drops the water and then simulates whether or not the water runs off, or something ridiculous like that. Wouldn't that be a funky way to solve this problem? Oh, there's a solve problem button. Emission count 4.1 liters. Practice. Hello, word bug. Oh, there's approaches. Oh, it also tells you how to do it. Okay. We try to do it without looking. Whoa. There's so many fairies. Hello, Nieves. There are 4 fairies? How many fairies are there? I mean, Okay, that is not what I meant to do. Hello, Hal. Oh my god, Hal, such a big fan. The human algorithm. Okay, hold on. Ooh. My original intent was to do this. Hello, Sora. But yeah, let's just try to, let's see if we can just do it. Oh, so here you go, Nieves, just for you. There's two of us now. I actually kind of like this. All right. Now I just need to do a thing where I can sound like... I just need my voice to echo so that I can sound like there's two of us. I'm definitely not procrastinating on doing the freaking algorithm. This approach is the brute approach. Um, Let me see. How would I do this? I make a new file. We'll trapping water.py. And then the idea is we'll be given an input. Oh, beautiful. Please log in to continue solving the problem. Must I? Ming, I can do it. Oh, I hate that. I can just do it. I don't need to sign up. Do I already have an account here? 1 second. No. I don't want you to have my get away. Um, no, don't use it. No. You perhaps get a password. Need one password. Be so kind. This heavy metal place. What is this banger that's playing? Thank you. That's all I wanted. All I wanted to do. Uh, huh. And websites have been giving me problems all day. Never trust a website. Like my graduation. What is this? Am I being interrogated? C++, beautiful. No, Python 3. Which we're anyways gonna. I just wanted, because I'm sure they will have test cases for us, and I love. Yeah, I love being given test cases. But yeah, oh, interesting. The idea being you take the highest tower, you take the difference between any two adjacent towers, and you figure you can trap water there, but you can also trap water in between any two towers. I think the best way to do would be to just go through each slot and try to model what happens if you drop a cube of water over it. You submitted a new FOIPA request on myself to the FBI, but under my new name. Thanks for letting us all know, Maddie. Yeah, there were some other example cases before WordBug where it was like, oh god, oh my god, dude. See, so like in this one, it's like this whole thing can be water, or in this one, this whole thing can be water, and this would be water. It's kind of like if it rains, how many blocks fill up, right? So yeah, so it can be at different levels, as I understand it. So this is what I want to do. I want to go for each element in the array. I want to see what happens if you drop cubes of water in it. And I think we can figure out an intuition for how to solve it. Like, let's think about it this way. It's like, okay, I check here, I drop a cube of water, but I see that for water to remain in place, there needs to be two walls higher than it somewhere, right? So here you plop a water, it wouldn't be able to stay. Here you plop a water and it has two walls next to it, and so it stays. So you get one cube of water. Here you can try plopping another water on top of it, and it stays. And if you plop another water on it, how do you determine if it stays or not? Well, you have one wall here and another wall here. As long as there is a second wall somewhere at the same height, the water will stay, I think. So one more block, and then again, there's only one wall at that height, so it wouldn't stay. Here, there are two walls that are as high as it, so it gets to stay here, here, here. So in one of the more complicated figures, like here, there are two walls. Here 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 there's one wall. Just one. But if there had been another wall the way over here, then yeah, everything would have filled up with water. So as long, well, let's see. Here there's one wall. Here there's two walls. Here there's one wall, and here there's one wall. So if we go through every little spot in the array and we try a water, we can build like our little water array. Well, we don't even need a water array. We just need to know if water was able to succeed there. We just need to count the number of water units, right? So let us try it. Let's start with this array, which of course we're going to do Pythonic list. Don't need a sub. What's, oh, okay, hold on. What's n? Where did everything go also? N non-negative integers representing the height of blocks. I don't understand where the 6 comes in. That's the, is that the height of the water? Oh, that's just the problem space. 1, 2, 3, 4, 5, 6, 3, 4. But I guess they give you the size because in because in C you would need to program the array before putting stuff in it, so it pays to know what size your array is going to be before you feed it the data. This is Python. We don't need that. Of course, we can still make use of it. But it's just what I say. So for block in R, what we're gonna do is need to be able to do this consecutively, but basically we say while, so we said overflow equals false. while not overflow. And we also do water as an int. While not overflow, so starting water height equals block plus.
Is he dead too? Who? The boy, Jason. Jason? In the lake, the one who attacked me, the one who pulled me underneath the water.
New water height. So this is the water height after hopefully collecting a block. If new water height less than here's where things start to get interesting, y'all. Here's where things start to get spicy. That's not a very new thing to say, but it's okay. Matter of fact, it's more than okay. Bring it in. There's two different fairies working on the problem. Now that there's two of us, but we fucked up. Our name tags are backwards. I wanted to be in the front, as in front of you. Look at that, I scooted closer. This is fun though. Anyways, this just I miss. So instead, we're gonna get an index. So, but so what I need though, it's a quick way to know to check backwards and forwards for walls. But I just need to find two values that are as high as me. Well, I guess I can do it quicker because I can start at the center. Oh, Java. Java. We kind of don't like Java. Maybe we just have Java trauma. But it's a good language. Every language is a good language in the hands of a skilled engineer. We do believe that. But we love Python. We're big fans of Python. But yeah, I don't need to go through the whole list. I just need to start spreading outwards from the point where the point I'm considering. And so actually, we're calling this proposed water coordinates. Should maybe be doing like keeping notes somewhere. But let me just do some comment. Set up initial counter for water. Step through blocks in the array and see how far you can raise the water. So the proposed water coordinates will be a list block of x and y, and so it actually be I, comma, this one. And honestly, we could just do this. We do this as a different structure. It's just, no, it's just 2 ints. It's just a list with 2 ints. That is exactly what I want. So if we will write a helper function called step out. This is like something I had to do. And for step out, we will pass the array. And we will pass the water coordinates. And we will pass the number of steps. And then what step out does is it complaining because this doesn't have a return, doesn't it? Pass. So you don't like the pass because of this. Pass, just keep passing, dude. Just pass the buck. What kind of stuff do you do with Java, Hal? Do you use it at work? Do you use it for personal projects? Oh, and so okay. We do if water if you know what? Why not? Let's be an N. Yeah. To be honest, that is one of the things that streaming we're trying to remedy with streaming because it's a little it like keep us motivated in some ways. There have been some challenges still, but I think we have been able to make more process in our personal projects thanks to like kind of doing this double thing like where I get to like work on it and show it off and it's part of like growing stream content and stuff like that. But like the main thing is that just keep coming back to it, you know? Like, it's okay if it takes forever to get anywhere as long as you keep moving. Uh, the other thing that I will say for Java is that to my understanding, is very useful if you want to get into Android development, which is a thing we're constantly like eyeing because it's like it'd be cool to be able to make apps for your phone, right? But it's been a while since we tried that. But someday we might find ourselves in the Android mines. So the idea is, at this point, if the water coordinate sub 1, so the first element, which is just I, plus step, if it's greater than n, yeah, indeed, Swift, I believe, is the main framework for iPhone application. Um, and I know nothing. I know like zero about Swift. I think at one point I like looked at some Swift code. I have no idea. Don't know what it looks like. Don't know if it looks like Java or C. Someday we might find out. But we're pretty meshed in the Android ecosystem, so I don't see ourselves having an iPhone anytime soon. Right. So if it's greater than n, return false. This is actually, instead of step out, we can just call it overflow. I'll do that. It actually returns true, right? That means it overflowed on the left. If water coordinate of 1, well, that means it overflowed on the right. Minus step, it's less than n. Return true. Otherwise, if this just keeps stepping out, but it won't. Do we need to step out in both directions every time? Or is it okay to only step out in one direction? Well, no, because the thing is, once you hit that wall, you're good. You don't need to keep checking in that direction. And I keep thinking like, okay, you do it with threads. You do a thread that moves forward, and you do a thread that moves backwards. And you can, and yeah, and you just move forward, and like, but it's like as soon as one of them returns false, oh my god, dude. Can I just plop the two calls in an AND statement in my while statement? Oh my god, dude, the possibilities are blowing my mind. That is so janky. Oh, and it just goes. It does recursion. We do it with recursion. Ah. um, hello. It's we can do it with recursion. Um, what the fuck was I talking about? I should. I wanted to make like a little Scully drawing. So uh-oh. I fucked up. I'm supposed to make an empty file. So like my point is if we have a structure like this and say I plop a cube of water here, I can then start a thread that I can just start a thread that goes start going this way and this way. And if even if it's like this, and I'm considering putting water like right here. They'll just go, okay, is this out of bounds? No. Is there a wall? No. And how do you check if it's a wall? You check array at this point, and if it's higher than array, that's 1, 2. This is 1, 2, 3. So you check if it's higher than array, then it didn't hit a wall. And then you just call it again. It calls itself again. Recursion. I love it. It calls itself again, and it like goes one more step. And same. Is it out of bounds? No. Is it a wall? No. And then it'll keep going, and then if it hit a wall, it finally returns some value. Say it returns, if it's overflow, it'll return false. And then same thing for this one. It'll just keep passing the buck until it returns false. And then 2 falses mean the water gets to stay, and then we can like plop another one on top and do it again. And this time it'll get the false signal from here, getting overflow in this direction. But in this direction, it will eventually hit out of bounds and return true. And that is our signal to move on to the next step in the array. With me so far? Good. So that means we have to send a thread. We have to send a search right, and it'll eventually return true or false. If they both return false, we keep going. If they both return true, that just means it overflowed. So But this does mean it also is the case that as soon as one of them returns false, you can stop checking. So by picking one, by picking a direction to check first, we could save ourselves some trouble half of the time. This is brilliant. We are so smart. We are like really clever. Yeah, keep going until it hits true, and then basically, I'll just pick left to go first, and then that means for about half of it, it will have been more effective because it will only have to have search one time. And then for the other half, it will be more effective because it'll be less effective, but it'll balance itself out, but it will be more effective than if I try to like wait for both of them. So only if the first one returns false do I need to stop. And let's go back. So I say, instead of calling it overflow, we're gonna make a function called check left, which takes the array, the water coordinate, and it takes n. And we might need, I think we do need that. Yeah. And what it does is if water coordinate sub 1 plus or minus step is less than 0. So this was an error here. Returns true, meaning it overflows. Actually, I think we should make this return false. You do need to check the entire length either way, but what I'm getting at, and I might be missing something, but my idea being that if I always have to check for each of these threads to return something, because I'm going to implement it as a return as a recursive function, unless Python can do parallel, but I think you have to tell it to do it parallel if it's going to do it in parallel. I'm not sure, actually. If it's in parallel, then it doesn't matter. But if it has to go here all the way till it gets true, and then it has to get all the way here to get false, and then be able to say, okay, so the water will overflow there. It could just do this, and once it hits true, it stops. And then, yes, it will balance itself out on the other side, because later on, or like, actually for this problem, checking left first, yeah, because here, if I'm checking left first, it's going to take like increasingly longer amount of time to do it. But I guess I could do like a complexity analysis. I would have to do a complexity analysis to be able to tell if it balances out or not. I was just thinking like, you don't want to spend time checking whenever you already have it. So even if checking the left side first gets worse and worse and worse, it's still better than always checking the left side first and then checking the right side, even if the left side already returned true. So however few steps you're saving as you go forward, because like the amount of steps you're saving by not doing the right side check afterwards diminishes the farther to the right in the problem you're working on. However much you save from that, however that's still operations that you get to save by only checking one direction first and then the other, right? And then only checking the other if the first one returned false. Check forward flow left. Returns true. And if water coordinates one, actually, if the current height of the water that we're proposing, all right, this is actually 0, dude. This is just left and right, and now we need to check up and down. So if the height of the water that we're proposing is 1, is less than or equals to the height at I minus step, and we need to pass that index I. The index that we're considering, it's in the array, yes, but it's the water coordinate minus step again. We're checking first to see if it overflowed by going out of bounds. If it doesn't overflow by going out of bounds, does it overflow? If it's less than or equals to first, I move here and first I check, are we out of bounds? No. Then I check, am I in a wall? Which is to say, the x coordinate of the water block plus the step, is it inside a wall? And you do that by taking that same coordinate but checking the array and comparing it to the height. You compare the y value of the water to the value of whichever wall it's there. And if it's the same, or if this value is higher, then you hit a wall and you can return true. You can return false. Oh, not here. Yeah, but what if you just step out back and then forward one and then back one and then forward one and then back one and then forward one and then back one and then forward one? Yeah, but I don't want to do it that way. And I'm not convinced that that would be computationally better. We need to figure out a way to, like, if we start having a conversation with each other, to have our avatars reflect that someday. We keep improving plural tech. Um, Someday we'll be able to do that. Hello, Favot. This is one of those rares, 1 in 100 Favot messages. So that's cute. Man, this music's dramatic. Check to see if we hit a wall. If it's equal or less than, then return false. Else, return Stack Overflow left r, comma, water core, comma, stat, and here, step. And this is actually, well, step does always increase. It's just here we're subtracting. Of course, it would make more sense semantically if check overflow right had negative steps. But then that would make the operation. So I'm gonna do it with step plus. So the water coordinates plus however many steps in the array, the value. If it less than n, if it's greater than n. It's less than 0 or greater than n. And then what we need to do here is We need a loop. Ooh, okay, so Twitch is informing me that ads are starting in 5 minutes, which means we have been streaming for approximately an hour because I used up one of my snoozes anyways. So we're gonna wrap it up here. And then when we do our next practice, we'll just pick up where we left off. This is fun. I find algorithm design fun when it's not frustrating, and I think I'm getting a little bit better at it, little by little. It'll be interesting. So next stream, we'll solve it, and then um, we'll look through the resources on the websites. Thank you, Sora, and thank you for hanging out and chatting. We really appreciate it. We appreciate uh, having other developers and coders and programmers in the stream. So tomorrow it's not going to be a coding practice. Tomorrow we're going to play a video game. That's right. I think the plan is for Ember to continue her Dark Souls 2 playthrough. So if you want to see us die a lot to a video game, tune in tomorrow at 14 Eastern Time. And for now, let me see if there is someone I can send you to. Someone doing like software stuff. Is someone doing something cool? Prince Susish is indie games. I don't know. I don't know what that's about. Talking to cute girls in the 90s. Your Sama is streaming. Tina Hacks is streaming. There's a lot of good people. I think I will send you over to Tina, even though she's not coding, but she's playing Final Fantasy. She's playing a cool Final Fantasy game, and she's a cool person. So go say hi for us if you would like, and we will see you all tomorrow. Have a wonderful rest of your Tuesday. If you like what you saw and you would like to catch our next stream, remember you can like and follow the channel. You can follow the channel by hitting the little heart icon, and you can like the channel by holding it in your heart. And yeah. Take care. We will see you tomorrow. Bye.